Okay, so this is brand new stuff for us. I'm going to go through it slowly. There's a lot of vocabulary. Okay, first vocabulary word is quadratic function. And a quadratic function is the equation y equals ax squared plus bx plus c. So we're going to be working on quadratics for like the next month or so. So we did linear equations, that's y equals mx plus b. Then we did exponential. Those were the y equals a times b to the x. The third big one we learn in algebra is quadratics. And that's the formula or the equation for it. Okay, next one is parent function. So it's just the most basic way to write this equation. And that is y equals x squared. Or sometimes, remember, they'll use f of x instead of y. Or g of x or whatever. It just still means y. It's the output. Okay, next one is parabola. P-A-R-A-B-O-L-A. Parabola. It is the curve of this graph. It's the shape of this graph. Bless you. It's called a parabola. Next one is vertex. When I have a parabola, that point at the end. Okay, thank you. This point right here at the very bottom is called the vertex, or if the graph is going down, it's that little top most part. Next, the axis of symmetry. The axis of symmetry that is, when I have my parabola, the axis of symmetry is, let me get a different color. It is the line that cuts the parabola perfectly in half. Oops, that is not a pretty graph. So it's the line that is cutting it exactly in half. We'll pretend like my graph is actually correct. That still doesn't look like. So if you were to fold the parabola on top of each other, it's just like where that fold line would be. Okay, next one, bless you, minimum value. minimum value is on the parabola that opens upwards. That dot, that vertex at the bottom, that is the minimum value. Maximum value, that's when I have a parabola that goes downwards. Well, it's going to be that vertex that's at the top. That will be the max value. For example 1, all of these graphs are going to look like g of x equals ax squared when a is greater than 0. Okay, so all of the graphs we're about to do are going to be when the a value is bigger than 0. If a is greater than 0, the graph will open upwards. When I have a positive a, the graph opens upwards, meaning like this. Okay, we're going to talk about vertical stretches and vertical compressions, but I don't think I'm going to have enough space, so I'm going to go to another page. I'm going to make sure everyone has this. Okay, that a value will do two different things. I'm going to split my paper in half. It will either cause a vertical stretch or a vertical compression. This is when the absolute value of the a is greater than 1. The graph will be more skinny or narrow. So when your a value is a number bigger than 1, a positive number bigger than 1, the graph's going to open upwards and it's going to be real skinny. So when I have a normal quadratic, like just the normal y equals x squared, it looks like this. But if I put in an a value that is greater than 1, it's going to make the graph get really skinny like this. The bigger the number, the skinnier it gets. Okay, then let's do vertical compressions. The compression is when the absolute value of a is less than 1, but greater than 0. So it's not going to be a negative. It'll be some fraction that's smaller than 1. If that happens, the graph will be wide or fat. So if I have my normal parent function, graph looks like that. If I have a graph where it's a fraction that's smaller than 1 but bigger than 0, it's just going to make the graph be wider or fatter. Okay, the domain and range for these types of graphs. Remember, domain means your x values. The x values that work for these types of graphs, you can plug in any x. You can put in negative 1,000,000. You can put in a fraction. You could put positive 1,000. So you can write it as all real numbers Or the way we were doing it before was it was from negative infinity to positive infinity. It just means you can plug in any number at all. There's multiple ways to write domain and range. So that's why I keep showing you different ones, because it really depends on your teacher. It depends on what book they're using. When you get to HMH, I think they switch sometimes as well. So that's why I'm just trying to show you the different ways. They all mean the same thing, but a lot of times it just depends on the way the book is set up. So x's, you can plug in any x. All x values work. Negatives, positives, fractions, decimals, everything. Okay, range, this is the important one with quadratics. Range is your y values. Okay, for these types of graphs, we're just talking about these ones. You have to keep in mind we're doing quadratics that open upwards right now. So when they open upwards, they have that minimum value down there. So that minimum value, that's the smallest y that you'll ever see. So there's a couple ways to write this. You could, the smallest value, which it's going to hit, so you could do a bracket, and then you can put your minimum value. And then the y keeps going up forever, so it's going to go up into infinity. Or another way the book does it, it's going to say all the y values, so y can be anything that's greater than or equal to that minimum value. Again, I haven't done the HMH yet, so I don't know when you go to do your exit tickets what it's going to expect. I think for this lesson they want it with this y is greater than or equal to. Okay, so now we're going to practice this. So again, all the ones we're working on right now are going to be, there's going to be a positive a. If the a value, the absolute value of a is greater than 1, it's going to be skinny. If it's less than 1, it's going to be fat. Okay, this is example 1a. G of x equals 2x squared. It wants us to graph and then find the domain and the range. Okay, we're going to create a table of values first. Okay, the x's I want us to look at will be from -3 to +3. Put in -3 to +3. And now grab Desmos, grab your graphing calculator, and you're going to put in y equals 2x squared and pull up your table. Okay, so I'm going to type in 2x squared. If you want to see what the graph is going to look like, wait, I got to change my window. Do -10 to 10, -10. Okay, your graph should end up looking like this. It's going to be skinny because we have a 2 in front. So it's going to be skinny and open upwards. Go into your table and fill in those numbers. When you're filling in your numbers, you should notice a pattern because it's going to be symmetrical, the graph, so whatever's on one side will be on the other side. So you should notice that 2 got repeated, that 8 got repeated, that 18 got repeated. The number that's not repeating, this is your vertex. Your vertex is the middle part, and then everything repeats on either side of it. Okay, we're going to graph this, and yes, you need to do it on paper, not on Desmos. So get some graph paper if you need some. I have some. Let's not do the one that goes up to 18. Let's just do up to 8. So make sure your graph, the y-axis needs to go up to, let's say, 10. So when you create your axis, give yourself enough space to go up 10. It doesn't need to go into the negatives, really, because there's no negative y values. So get your graph paper. I'm going to be coming around to check your graph. So don't just sit there and expect me to do all the work. So make it nice and tall. And then plot those points. I could leave off the 18 one. That's just going to be gigantic. When you go to connect the dots, you're not using a straight edge. Don't make straight lines. It is a curve. The parabola is a curve. So as best you can, connect it with a nice curve. And then also make the line go on forever, because it goes up forever, so it gets arrows on it. So these graphs usually are not so pretty. They're a little messier looking because we're trying to make that curve. And then when you're ready, you can cut that out and glue that into your notes if you like. And then we'll do the domain and range in a minute. Okay, domain and range now. Domain for all of these graphs, these quadratics, it's always going to be all real numbers because you can plug in any x. Domain is all real numbers. Because if you look at the table, I can keep going into my negatives forever. I can find a value for any of those x's. Or I could go positive forever. So any x value in there will work. Sometimes it's written as negative infinity to positive infinity, and infinity always gets parentheses because you can't touch it. Okay, range is always the tricky one. Range, we always go from the smallest number to the biggest number. So if I'm talking about the y-axis, if I look at the y-axis, the smallest y that it ever hits is right here at y is 0. So it does hit 0, so 0 gets a bracket. And then it hits forever going up. There's always going to be a y value forever going up to infinity. And infinity always gets a parenthesis. Or the way I have a feeling the exit tickets are going to want it written is y can be anything that is greater than or equal to 0. Y is anything greater than or equal to 0. Okay, 1b, g of x equals 1/2 x squared. So now my a value is smaller than 1. So that's going to be a compression, so that's going to be a fat graph. So it's positive, so it's going to open upwards, but it's a fraction that's smaller than 1, so it's going to be wider out there. Let's come up with our table of values. These ones, let's go from -3 to +3. Okay, fill those numbers in. I'm going to put a half in parentheses. I always put fractions in parentheses. 1/2 x squared. First, if you look at the graph, it should be fatter. If I go into my table of values and start writing those down. You'll probably notice where they repeat. Those repeating y values, the one that doesn't repeat, that's your vertex. A lot of these right now are all going to be 0, 0 as your vertex today as we're starting to practice this. But going forward, the vertex is definitely going to change. Okay, this graph, it doesn't need to be too big. Looks like our biggest is going to be probably 5. So grab graph paper. It only needs to go maybe 5 in each direction. Okay, so check. It should be a curve. It should not be straight lines. And then there's arrows on both sides because this graph goes on forever upwards. And then let's do domain and range. Domain is always going to be all real numbers for these. Or negative infinity to positive infinity. If it's a paper test, I don't care which way you write it. I'm trying to show it all because I don't know how HMH is going to ask you to do it yet. And then range. Range is the y values. So the smallest y value I see is 0, and then it goes on forever. So you could either do 0 to infinity, or y can be anything that's greater than or equal to 0, whatever that minimum value is. Other people, so if you want to go move and sit near a friend right now, you can. For these, I'm going to give you 2. You need to graph it on graph paper, not on Desmos. And then I also want to know what's the domain and what's the range. You're going to have 2 to do. Number 1 will be y equals 3x squared. And then when you're done with that, there'll be another one up here. Okay, go ahead and move around. You can work with people. I want to see the graph on paper, not on Desmos, and the domain and range. Okay, so for the y equals 3x squared, 3 is positive, so the graph's going to open up, and 3 is greater than 1, so it should be a stretch. So your graph should look something like this. The domain is all real numbers, and your range could either be y is greater than or equal to 0, or you could have it's from 0 to infinity. Questions on that one? And then the second one, this graph was fatter. It's a compression. Domain is all real numbers, and the range is y is greater than or equal to 0, or 0 to infinity. Okay, so all of these ones that we've just done is when the a is positive. Now we're going to go on to example 2 where a is negative. Okay, for these graphs, it'll be g of x or y or whatever they're using is ax squared when a is less than 0. So for all of these, a is going to be negative. When a is less than 0, so when it's negative, the graph opens downward. When a is negative, the graph is going to open going down. So it's going to look like this. And again, there's 2 different things. There's a vertical stretch and a vertical compression. is when the absolute value of A is greater than 1. If it's greater than 1, the graph will be skinny. So these graphs, so the normal parent function, the y equals x squared, that parabola looks like that. But if I'm talking about A is going to be a negative, and then the absolute value of A is greater than 1. So it's negative, but it's a number where if you take off the negative, it's bigger than 1. It's going to go downwards, and it's going to be skinny. So it'll be something like this. It's going to face downwards, but it's going to be skinny. Then if the absolute value of A is less than 1, but greater than 0, the graph will be fat. Or wide. So same thing, a regular quadratic looks like that. If I have a negative, it's going to go downwards, and then if it's a fraction that's smaller than 1, it's just going to be, oops, that doesn't look good. It'll face downwards, and it'll be fatter. Then the domain and the range for these types of graphs. Domain will still be all real numbers, because you can plug in anything. Or you can do negative infinity to positive infinity. The range for these types of graphs, so when A is negative, the range will either say, so you have to think about it, the graph's going to be going downwards. That'll be your maximum value at that top where that vertex is. So the y values will be anything that's less than or equal to whatever that maximum is. So one way I think they're going to ask you to write it is going to be y can be anything that's less than or equal to the max value, or it's from negative infinity up into that maximum value. And it does hit the max value, so the max value gets a bracket. This is 2a. G of x equals negative 2x squared. We're going to graph it and state the domain and range. So it's negative, so that means it's going to go down. And that 2 being greater than 1 is going to make it skinny. So it should be going downwards and it should be skinny. Let's come up with our values. For the x's, write this one down. There it is. Let's go from negative 3 to positive 3. Okay, use Desmos or your graphing calculator and go to the table. Okay, if you look for the repeated y values, you'll figure out where the vertex is pretty quickly. So your vertex is at 0, 0. Okay, get some graph paper. Let's not do the negative 18s. So if you look at the y values, they're going to go down. I would say make your y-axis hit at least negative 10. Okay, I wouldn't do the negative 18s, but do the rest of them. Negative 2, 1, 2. And then connect them with a smooth curve. I do need you practicing doing the graphing by hand, not just in Desmos. Bless you. So it's negative, so the graph is coming down. It's a 2, so it's skinnier. And then let's do domain and range. Domain is going to be all x values, or all real numbers, because you can plug anything in there. Or you can do negative infinity to positive infinity. Okay, range is going to be the y values. If I want to do it, let's see, from negative infinity, it's all, because this arrow goes on down forever, so it's negative infinity, and those y values keep hitting until I get to the vertex of 0. So you can either write it as it's from negative infinity to 0. Infinity can never be touched, so it always gets parentheses. 0, it does touch it, so if it touches it, it's a bracket. Or the way I think HMH is going to ask you to write it is going to be y can be anything that is less than or equal to 0. Okay, I think we're going to stop right here, and we will continue with this lesson tomorrow. Don't throw out that graph paper. So if you still have some graph paper left, save it in your notes.